Why, hello again. Yes, I'm back in my shop. The weather is really being nice right now. The humidity's really dropped substantially. It's going to be in the 50s tonight. I love it. The whole week is going to be good. Well, while I'm waiting I got to touch base with Bob. I got the tubes in for Bob's radio today. They just came in. But I got to see Bob tomorrow, and then I'm going to start on his radio again. What I've been doing today, I'm working on this oscilloscope. You know, I almost totally gave up on it. I came that close to giving up on it and thought, well, it's the damn CRT. It's got to be, because I'm checking everything else in the circuit. Now I'm waiting for the 200 volt Zener to come in. In fact, I happen to order 10 of them because that's the way they packaged them. And the price was really reasonable from eBay. And I had one of my viewers offer to send me one, but I got an email from him, but I appreciate it, thank you. But unless for some reason these aren't the right ones, I will be getting a hold of them. But I appreciate that. Now, I know that the scope isn't going to be working right until I get that Zener in there. But I'll tell you what I found on this, and it was totally by accident. Let me take you over here. Okay, I'm waiting for the Zener diodes to come in, and it goes right here. These are the three Zeners that are good. These are 150 volt Zeners. This is the 200 volt one here. So it uses the three diodes here, Zeners for 150 volt, which I found out later, the numbers of them, thanks to my viewers. They were able to see things that I couldn't see. And of course, a CR311, which is the 200 volt one. Now, I'm going to take you over to the schematic here. All right, you may or may not be able to see this good. This is a terrible schematic, but one of my viewers gave me a better schematic of this area here, so that's able to find out the diodes, the other three Zeners. Okay, but this is the original schematic that I scanned. Mike had told me to check in the circuits here, and the cathode, I checked all these resistors here to see if they were off value, but I figured, well, maybe because I wasn't getting any display, maybe the cathode was open. Filament lights, so I figured, well, maybe the cathode circuit is open. So cathode is pin 2 or 3, I can't see that. Pin 2. Okay, cathode is pin 2. I took the cap off, the socket off the back of the CRT over here, and stuck a meter probe in pin number 2 of the socket, traced out the circuit to this a ceramic disc, which is the big disc on the board, and I traced it out to this one here that I stood up. Okay, that's a 0.015, I think it's 3,000 volts. The print is horrible, you can't read it. 1.6 thousand, it looks like. Okay, and then it goes to the Z-axis input. Alright, so I got a reading from here to here. And before I did all that, I checked the pins, and I thought maybe there would be corrosion on the CRT pins, but there wasn't. It was nice and clean. But I took a small rag and I put a little deoxide on it. I just wiped all the pins down anyways. Socket was nice and clean. So from pin 2 to this capacitor, which is here, I get a straight reading, and here is the other side of that capacitor goes to the Z-axis jack on the front panel. The other side of that capacitor right here that I got standing up here, the one I had to lift up in order to get at the Zener, which is been removed and broken up. That goes between here and here. And this area here, this black here I drew that with a marker to see that the band goes to the right. All the diodes, the bands go to the right, but a notation, I marked that here. So that capacitor connects to pin 2. So I got continuity there. So, and I checked all the resistors coming off of the cathode in case any of them are open. And I ended it here. Everything seemed to be okay up to here. My next step was, okay, could this tube be in cutoff? So I said, maybe it's in cutoff. Now the cathode is so many hundreds of volts off of ground potential, but it don't tell you that here. They don't give you voltage readings here. The only voltage readings you get is you're supposed to have 780 volts right here at this test point. 780, and I'm only getting 700. Okay, so that's negative 700 in reference to the chassis ground. So I'm saying, well, maybe this is probably about the same, or thereabouts. Okay, so I'm supposed to have negative 43 volts here to chassis. But of course I got a capacitor here. So you're not going to get negative 43 volts at this point because you got a capacitor here. Now this Zener here, number 4, the CR311 is a 200 volt Zener that I'm waiting to come in from eBay. So basically that part of the circuit is open right now, and this is a regulation circuit here. Thanks to some of my viewers, and also Brendan emailed me and gave me some pointers on this. So this wouldn't necessarily stop the scope from giving a display. So Brendan had told me, if I understood him correctly, you should still have something on the screen even if that Zener's no good. Well, I didn't. But there's no voltage readings on these pins. Now, I'm not concerned with the focus. I'm concerned with the control grid, because that's where your intensity control is, so that adjusts the bias for the control grid. All right. So I took my VTVM, turned it to 1500 volts. Which would be safe. I said, if I'm going to get 1500 volts on that or on the cathode, I'm definitely not going to get 1500. I'll probably get 780. Well, I only get 700 at this point here. I don't know. At this point here, with reference to ground, my VTVM showed 425 volts, and that varies with the intensity control. It goes well over 500 if you turn the intensity control up, and turn it down, it goes below 400. But that's with reference to chassis now. I did not reference it where you should reference it from the cathode to here. In order for me to do that, I would have to use my digital meter, not a VTVM, because the VTVM is grounded. So you'd use like this here. Okay, if you're following me so far, what I did is I put a clip lead on the grid. This is the grid wire. This goes directly to pin 2. Did I say pin? Let me just make sure I'm talking right here now. No, that's cathode. I'm sorry. Pin 3. Pin 3 is the grid. I also checked pin 2 to trace out the circuit for the cathode to make sure that the cathode is, the resistors are okay. And they are. Okay. The grid. Okay. Pin number 3 is the grid, the control grid of the CRT here, which is a 4-inch CRT rectangular. That's here. This goes right to pin number 3 of the CRT. So I put a clip lead on that. And I put my VTVM on there, okay? I'm going to turn the scope on. I'm going to put the switch on now. Watch the meter. Okay. What I'm getting 475 volts right now. All right. 475 volts on the VTVM. Look what I got on the screen. Kind of a bad trace. I mean, it's got a non-linear scan here. But I got something. And the intensity control works. And as you can see, I turn it all the way up. And I'm down to about 425 volts. And turn it down and I go over 500. Okay. I was looking at the meter. And I said, wow, I got a trace. Watch what happens when I take the VTVM off. The clip. Now it's not going to come off now. Isn't that something? There it is. Nothing. It disappeared. Okay? In other words, the tube is in cutoff. The input impedance of the VTVM is 11 megohms. All right? So I said, okay. It is probably due to that Zener diode not being there. I'm hoping that when I replace the Zener diode, my bias will be correct on the control grid. That's my method of madness, my method of thinking. All right, we're not done yet. I want to show you something. I pulled out a 10 megohm resistor out of my junk box. There we go. So by shunting out, bleeding off some of that voltage, I guess, off of the control grid by way of a 10 meg resistor, and this runs cold, there's very low current here, we've got a working scope. Now, if that Zener don't take care of it, and I couldn't find any other resistors, they're very hard to check, and I think I'm still on macro. Yep. They're very hard to check because I have to scrape each end of each resistor with this screwdriver in order to get my meter on there, because they got the varnish on there. So if replacing the Zener still don't correct it, but I have a feeling it might, then I will have to solder this in permanently across the grid to ground. That's where it is right now. It's connected from the CRT grid to chassis ground. Okay? Now, I got a hell of a time here trying to get the DC balance. I'm used to DC balance. I don't know what the EF balance is, but that's another problem for later on. But when your DC balance is off, your volts per division, your baseline changes. See, each time you move that, and it's not supposed to. And it goes right off the screen when you got it in the last two positions. You can get it back. All right? And when you get it back here, then you lose it here. So you got to go in the next range and bring it here. I juggled around both of these adjustments. But I don't know what EF balance is. I know what DC balance is because I've worked on a number of scopes, and you get that right. And when you adjust that DC balance, this baseline is supposed to stay rock solid. It's not supposed to go up and down when you change your volts per division, nor on the vernier. See, the vernier does it also. See that? The vernier dial. See that? Just moving it a little bit. Move it too much, it goes right off the screen. So you have to constantly set it. All right? So That and the non-linear sweep. But these are things I'll have to look into later. But I wanted to give this video a little bit of demonstration here to show you that all the while I seem to be getting high voltage. All my low voltages are okay, but I was getting no display. The zener was open, was bad, so perhaps when I do get that zener in, and if it isn't physically too big, I think it's a 5 watt instead of a ½ watt. If it isn't too big to go on this board, and it corrects the problem, I'm all set. Looking at the bigger diagram that one of my viewers gave me, it's a little bit clearer. You can see the string of resistors from the top to minus 43 volts all the way down to the 220K. And these diodes are just voltage regulation. I'm hoping that CR311, when I replace it, will fix it and I won't need to use this resistor. But this was a total accident. I was just using my VTVM here to check the grid voltage. So I think the next step for me to do is to check the cathode voltage, and I can do that off camera and give a report about that in the next video. But anyways, that's that. And of course this sweep control is very, very hard to turn. Okay. And that's a continuous sweep, and this is a triggered sweep. There's nothing going in it right now. Now this automatically puts in the calibrator even though you don't have anything in it. But it seems to be an AC calibration, but it's a weird one. Let me see if I can... See how that is? See that waveform? I don't know if that's supposed to be a square wave or not. I'll have to look on it. I thought it was. And I think it's supposed to be 0.04 volts with the position switch up and 0.4 volts with the position switch down. It looks like it gives a stronger one going up. But you can see you've got a weird display there. And I'll switch this over. See, this is kind of screwy yet. This scope is a little bit screwed up, to say the least. But when I fed in my function generator up there and fed it in here, I got the square wave, I got the sine wave, and it didn't look all distorted like it does here. All right, so I just wanted to touch base on that. At least I got some progress because I was getting my voltage. Now you remember this, I never did any more with it. I got the high voltage caps and I got the high voltage diodes. I just haven't done any more with it. I was thinking of combining the high voltage supply, which would be 8,000 volts, a voltage doubler from the bug whacker transformer. But this will read 10,000 full scale. So what I did here, a while ago, I ordered a 100 megohm resistor. This is the one I made up, and you saw this when I was talking about this power supply here. So this is the resistor I was going to use in it. Well, I was thinking of making this into a 10,000 volt maximum high voltage meter, as well as a high voltage power supply to generate the several thousand volts in case I need it. 4 to 8,000 to be exact. So what I did is I just took a clip lead from the ground side of this meter, which is a I think it's 100 microamps. Not positive now, but anyways, with 100 megohm resistor in series, I got this off of eBay a few months ago, and the other end grounded, I was reading where the 20 is, I was reading the next division up over that. So I was reading about 2400 volts. So the high voltage is correct and fairly close. So this is my makeshift high voltage probe for now. It's not, I want to get it all together, but I haven't figured out how I'm going to switch over from having, see this meter, this resistor's got to be in this circuit at all times. And it's going to come off of through a rectifier and a capacitor. This resistor does nothing more than reduce the voltage at this meter. Just like this one did that I had in there, the one I made up with 1/4 watt resistors. This is pretty much right on 100 megohms too, but I figured I'd rather get something like this, it'd be a little better. So I simply took and put this under this lug here, ran a clip lead underneath inside the scope, stood this up, and I got 2400 volts off the second anode. So we know that the high voltage is working in this, and I figured, well, I wasn't getting a display, and had I not used my VTVM today to check the cathode, the grid voltage and the cathode I'll be doing, if I wasn't using that, I was just about to write this scope off as having a bad CRT because there was nothing else that it could be. This is supposed to, okay, there's a trigger right there. Actually, it's not triggering. It's not really triggering. It's triggering, it's supposed to internally trigger on the plus side of the rising part of the waveform, and it isn't. Don't seem to matter. But, these are issues, I'm going to have to deal with. But anyways, I'm getting off the subject here. But if you guys have been following me on this, wouldn't you think that this is logical? That perhaps when that diode, that Xeno diode is back in circuit, once I get it in the mail, that maybe I won't have the tube in cutoff anymore? I'm hoping so, otherwise I have no idea what other parts could be at fault. And worst case scenario, I'll have to permanently solder this resistor in across the grid, but I don't really like to do this from grid to ground. All my controls work. The only thing I don't like is you turn this brightness down, the left side of the trace stays on longer than the right. See that? See how it disappears? I really don't know. I mean, I've had oscilloscopes for many years, but it could be, maybe it's part of the, let's shut that off here. Let's just do a baseline here. Let's get that down where it should be. Let's turn the brightness down now and see what it does on this. Same thing. This is the last part to go out. All right. Well, anyways, taking that resistor off is the same as taking off the VTVM. VTVM is 11 megohms. I said, well, hey, what if I put a 10 megohm resistor in there? I didn't have 11, so it's in 10. And if I take it off, the scope is out. Nothing will bring the trace back. So I really thought I had a bad CRT. All right, I just wanted to give you an update on this. I know probably a lot of you is probably sick of it, but I do get a few of my viewers that are still interested in seeing this scope running. And I appreciate that because nobody wants this thing running more than me. Thanks for watching.